there. In this tutorial, I'm going to discuss about dynamic NAT, how to implement dynamic NAT. Now, we already learned about static NAT, how to configure static NAT, and we saw that we purchased some IP and we configured a particular local PCs. We assign particular local PCs for those IPs. So NAT is network address translation, and basic thing about NAT is for example, if these two PCs wants to access the public network, then we want a public range IP or any range IP which we think that is good for that network. So we don't want this 10 network to be exposed in front of public network, but we want IP of which we might purchase from the ISP to use for the public network. Now, in static routing, we learned about that. For example, if we have a IP range of 120 0.10 to 120.0.13. Okay, so for example, if we purchase these 10, 11, 12, 13 4 IPs from ISP, and if I am going to configure it from static routing, then I might have 4 local PCs. So when I go to router, I assign all 4 computers of my local network. I assign all the purchase IPs for my local computers, so that whenever these local computers goes to the public network, they communicate with these purchase IPs. Now, for example, if I have 8 PCs and I implement NAT from static routing, then it's very difficult to all the time goes to router and configure NAT for 8 computers. Here in dynamic NAT, for example, if you have 8 computers and if you purchase 4 IPs, then it means that any four out of 8 can use internet, can use to communicate public network, but it would be only 4 out of 8. Means it could be at random, whatever it is, but only 4 of my choice, or only 4 of according to router's thinking that these PCs are active and deserves these public or purchase IPs, so let them communicate. So for dynamic, you have a choice, good choice, to let the computers to go and communicate the public network, but remember, only 4 out of 8 if you have a 4 IP ranges. It's according to your concept. But in static route, you have to all the time goes to routing. Static NAT all the time goes to routing, and all the time you have to configure those every time. So let me configure the dynamic one. 3 basic commands is needed to configure dynamic routing. First is access list. Now, we already learned about the access list concept. Access list, how to deny a network. It's a set of rules which can be used to deny a network, to permit a network, and here we are doing it to permit our local network. So access list, for example, I give a number. I'm using number ACL, and I'm going to permit a network of tens, so tens 0, then 1 commas 0.255, the 255. So welcome your broadcast mask minus subnet mask equal to welcome mask. So done with it. So first command is done. Okay, we have 3 commands to do this. One is done, second one. Now second is IPNet. I have to create a pool of these ranges. This is what I purchased, I get from public, whatever I do, whatever it is, whatever your concept is. So but I just imagine these IPs weren't going to use. So okay, so 120.0.10 to 120.13, and the NAT mask of these ranges are 255.0.0. So they are class A IP, or if you're done subnetting, you can do subnetting. Sorry, we forget to name this pool. For example, I want to name it as Tech Engineer TV. So okay, we just create a pool. So IP NAT pool, pool's name, pool's range, NAT mask is 255.0.0.0. okay, all done. So second command is done. Now the pool is the concept of pool is, for example, this is 10's network, and this is a web server. Currently routing is enabled, and this server can communicate this PC. This server knows that this PC's IP is 10.0.3. This PC knows that this server knows that this is 10.2, and whenever these PCs communicate with the web server, they always communicate with their real IPs, which is 10.2 and 10.3. Here we are taking a scenario that, for example, me don't want these PCs to access this web page from 10's range of IP, or from 10's to whatever it is. So I just want a public network, a public line to get to know about these PCs via these IPs. This is very much important. Not only and you can see these changes are up, and this is very much important not only to hide from tracking. If someone tracking you, probably virtual IPs are very much likable nowadays. Importantly, it's importance are drastically increased. Virtual IPs, or you can say that you purchase these IPs, and via these IPs you can hide the main identity of your local machine. Now that third command, which is what we need to do, is IPNet. Now inside source list, IPNet inside source list, and the range of our access list, which is our access list we gave 1. So our source list will be 1, and pool name is Tech Engineer TV. So all is done. Our third command is done. Now our first command was access list number, permitting the local network, and welcome mask. Our second command was IP NAT pool's name, pool's range, IP which we purchased from Pubcaster or ISP, NAT mask of the range, and that's it. The third command was IPNet inside source list. List means access list number, pool's name. Okay, now we need to configure NAT inside and outside. So fast Ethernet, for example, let me start with 0/0. I'm configuring the serial port so that our packet filter from outside. So outside, exit IP NAT interface fast Ethernet 0/0 IP NAT inside, exit. Now literally, since routing is enabled, these two PCs should have communicated with 192.168.0.10 with 10's range of IP, but let's see. Currently exit from it here. Okay, now when you tries to show IP NAT translation, then we find nothing is there because we not yet started communications. So let me 20s okay. We need to ping with this web server. Just pinging. Twice to open a web server, web page. There we go, it's done. Pinging. Web page. Okay. Let me find out show IP NAT translations, and you can see these translations. Before we didn't find any translation because we not yet do anything. Now here is the list, very important one to understand that. Now you can see there is a 4 column actually. 2 column is inside global ICMP. We just ping it, and the IP range we purchased 120.0.0.10, the port number which we used, and the inside local, the IP range is 10's3. Okay, you can see 10's3, the inside local, and this has been done with same PCs you can see here, not from 10's2. But when you do that ping with 192.168.0.10, and we're pinging with so when you so new list found. So what thing has been done now? When you find out the 10's3 means this PC for inside the global is 10's3, means at inside network, at internal network this PC is 10's3, but inside global means at this router, whenever it reaches to the router end, then it becomes 120.0.0.10. Okay, now regarding outside global, this is web server, and outside local and outside global. Outside local is IP same 192.168.0.10, and outside global its IP is same 192.168.0.10. So nothing is changed for the web server, but it changed for the local network we configure. You can see here these are the port numbers, 10s, 11s, 12s, change according to the sequence. You can see 1, 2, 3, 4, 5, 6, 7, 8, and you can see the sequence here be same 2, 3, 2, 3. So sequence are same because we are doing this with ICMP, means we ping. That's the reason the port number is according to the sequence. Now you can see when you try to find out the TCP, then we find that the web page port number is same 80, but TCP's the internal the our own network's port number changes all the time. Here also you can see that 120.0.0.11, which is another IP range we purchased, and the local will be 10s2. So it's you can see there is a difference. 10s3 and 120s 10 means the sequence is changed. It should be 120.0.0.0.10 for 10s2, but the router assign this range to 10s3. Now if we connect 8 PCs out there, then any 4 can communicate with the public network. Any 4 can communicate with the public network with the same ranges, and rest of will have to wait till the first 4 completed their job. So its sequence, you can see, it's nothing is fixed. You can even change these IPs later. You can see it dynamically done. So router dynamically assign routing the ranges which we just gave it as a pool.